So differentiating inverse trigonometric functions. Okay, so just a reminder of what an inverse trig function is. So what we call the arcsine of x, okay, arcsine of x, let's say if this is equal to y, this means that x is equal to the sine of y. Okay, so basically I'm giving you the sine of an angle and I want you to find the angle. Okay, it's what you called in high school, you call this, you wrote like this, sine minus 1 of x. That's what you wrote. You remember? You remember this, right? That's what you did in high school. Okay, so let me give you an example with numbers. It's always good to see a numerical example. So for example, the arcsine of 0.5 is equal to what? Can you tell me?
Was it 30?
Okay, so it's 30 degrees, very good. So in other words, you're asking yourself, what angle should I find the sine of to get 0.5? Okay, so the sine of what angle can be 0.5? So you're right, it's 30 degrees, but we're going to put everything now in radians. So it will be pi over 6, okay, which is 30 degrees. Okay, and so there's the same thing for, there's arcsine, arccosine, arctangent, arcotangent, arcsecant, and arccosecant. Okay, there's every trig function has an inverse trig corresponding to it. Okay, so what I want to do now is to find the derivative of such functions. Okay, so I'm going to list them here, and then I'm going to prove each of them. So there's 6. Let's prove all 6 of them. Okay, so first one, if f of x is equal to the arcsine of x, then what's f prime of x? Same thing with if f of x, I'm going to do the arctan, then what's f prime of x? And then if f of x is the arcsecant, then what's f prime of x? Okay, so I'm going to give you the answer for each one. So the derivative of the arcsine will be 1 over the square root of 1 minus x2. Okay, it's pretty weird, but that's what it is, and I'm going to prove it. Arctangent, the derivative is 1 over 1 plus x2. Arcsecant is 1 over this x times the square root of x2 minus 1. Okay, so these are the 3 basic ones. And I'm going to write down all the cosine, cotan, and cosecant. Let's do it on the side here. You're going to understand why I'm labeling it like I'm displaying it this way. Okay, so R cos, R cot, and R cosecant. Okay, so the arc cosine is the exact same thing as the arcsine, but with a minus. So same thing, 1 over root of 1 over minus x2, but with a minus in front. Same thing, arc cotan, same thing as the arctan, 1 over 1 plus x2, but with a minus in front. And the same thing for the arc cosecant. square root of x2 minus 1, but there's a minus in front. Okay, these are the 6 derivatives. So what I'm going to do now is I'm going to prove all of them, and then we're going to do some practice on applying them, right, to find derivatives of more complex functions. Okay, so move up a bit. So proof. So if f of x is equal to the arc sine of x, then I want to show that f prime of x is 1 over the root of 1 minus x2. Okay, so let's go. So I'm going to call arc sine of x, this will be y. So I'm looking for y prime. Okay, so I know that if the arc sine of x is equal to y, this means that x is what? What's x? We wrote it above.
The sine of y.
Very good. Sine of y. And so now I'm going to do implicit differentiation. I'm going to derive both sides. So the derivative of x is 1, and the derivative of sine y is what? Cos y, right?
Negative cos y.
No, it's cos y. The derivative of sine is cos. Okay, so I'm waiting. So obviously something's missing.
Y
You have
prime.
to put like a y
Okay.
prime.
Times y prime. Okay, don't forget the y prime. Okay, it's changing, right? Sine of y times the derivative of y. Don't forget, y is a function. Okay, so times y prime. And so y prime is equal to 1 over cos of y. Are we okay so far? Okay, who's got questions here? Because this little process, we're going to do it for every proof. All good? Okay. So now look at what I'm going to do. I'm going to do something crazy. I'm going to draw a little triangle, a right triangle. Okay, with 90 degrees. Yeah, right triangle. And I'm going to put an angle here, y. Okay, so I'm going to use this triangle to illustrate the relation here. So don't forget, sine of y is equal to x, but the sine is equal to always the opposite over the hypotenuse. Okay, so if I want this to find this relation in this triangle, where should I place the x? I should place the x here. I should put x here, and here I should put a 1. That way, I see that the sine of y is opposite over hypotenuse, so x over 1, so it doesn't change. It's fixed. It fits with what's written here. Do you understand what I just did? Okay, so again, I have sine y is x, so x over 1. So sine y is x over 1. Sine is opposite over hypotenuse, so the opposite is x, the hypotenuse is 1. Opposite is x, hypotenuse is 1. Questions? It's important this. okay? Because you're going to do this in calculus 2 a lot, okay? This little thing that I'm doing. Okay, anyways, we're going to do it more with these. So now that I have 1 and x, then I could find this using Pythagoras theorem. Okay, so now this is going to be square root of c squared minus b squared, so 1 minus x2. Are you with me? And so now I could find an expression for the cosine of y. Okay, so the cos of y, don't forget that the cos is always equal to the adjacent over the hypotenuse. And in my case, the adjacent is square root of 1 minus x2, and the hypotenuse is still 1. And so I have y prime 1 over cos of y, which is, we just show that it's square root of 1 minus x2, and I'm done.
Can you just repeat the last step, please?
Excuse me?
Can you just repeat the last step?
The last step here, this?
Yeah.
Okay, I just showed that the cosine of y is square root of 1 minus x2 over 1. That's it. So I replace cos
okay.
y by this, and I'm done. Okay, so I just showed that y prime,
Okay, thank you.
y prime, yeah, is equal to this. I proved it. It's done. Any questions? Okay, that's it. So now this little process that I just did, we're going to do it 5 more times. Okay, with of course different functions here. So let's now do the arctan. Okay, let's do the arctan. So let's go proof that if f of x is equal to the arctan of x, then f prime is 1 over 1 plus x2. Okay, so this is what I want to prove. So same idea. Arctan of x equals y. This means that x is equal to the tangent of y. And I want to do the derivative of both sides. So 1 equals, the derivative of tangent is secant squared of y times y prime. And so y prime is 1 over secant squared y. Guys, okay? And I'm just going to remind you one of the identities, of the trig identities that we proved, and remember that secant squared x is 1 plus tangent squared x. You remember this identity? Okay, so basically, this means that y prime is 1 over, so secant squared is 1 plus tangent squared of y, but tangent y is x. So y prime will be 1 over 1 plus tangent x squared, right? Tangent y, which is x, squared. Done. I just showed. Okay, so you might be asked on the test to prove this, okay? So you have to know it.
Can you repeat the last step? Like, how did you turn the 1 plus tan 2y to 1 plus x2?
Okay, so tan y is x, right? Understand? Tangent of y is x from here. No?
Yeah, I get it.
Okay, so if you square here and you square there, so tangent squared is equal to x2. You get it?
Yes, thank you.
You sure? No, you have to be convinced.
Yeah, I get it.
Okay, good. So that's it for the second one. Let's now do the arc secant. So if f of x is equal to the arc secant of x, then let's show that f prime is equal to 1 over x times the root of x2 minus 1. Okay, so let's go again. Arc secant of x is equal to y. This means that x is equal to the secant of y. I'm going to derive both sides. The derivative of x is 1 equals derivative of secant is secant times tangent times y prime. And so y prime is 1 over secant times tangent.
Sir, could you go down a bit? It cuts off the bottom.
Sure, thank you. There you go. Okay, so that's what we have so far. Now secant y, we know that that's x. So this I can replace right away by x, which is probably going to be this x. And then I have to find an expression for the tangent of y. Okay, you with me?
Yes.
Okay, so let's go. So for this, I'm going to do a bit of work. I want to go back again to the little triangle. So here, x is equal to the secant. If you remember, the secant is 1 over the cosine. Okay, and so this means that the cosine of y, cos of y will be, if you send the cos here, the x down here, I'll have 1 over x. Okay, you with me?
Yeah.
Okay, so let's draw a triangle where the cosine of y is equal to 1 over x. So I'm going to draw it. And then from this triangle, I'm going to try to find what the tangent of y is. So this is y, this is 90 degrees. And let's go. Cosine is equal to 1 over x. Where am I going to put the x? Where am I going to put the 1 here? Okay, remember that the cosine is the adjacent over the hypotenuse. So adjacent 1, hypotenuse x. And then I'm going to use Pythagoras here to find this side. C2 minus A2 equals B2. And so I'm going to have here the square root of x2 minus 1. Okay, to use Pythagoras theorem.
So how did you get the root x squared minus 1?
Excuse me, how did this?
How did you get root? Yeah, that.
That I use Pythagoras theorem. This squared minus this squared, square root. Pythagoras theorem.
Okay.
Okay. Okay. So that's I need the tangent of y. Okay. And the tangent, if you remember, is equal to the opposite over the adjacent. That's the tangent. And that will be opposite over adjacent. And so y prime is 1 over x, right? Secant y is x, times tangent y, which is square root of x2 minus 1. And that's it. That completes the proof. Are there any questions?
Yes, I have a question.
Yeah, go ahead.
Okay, so
I'm sorry, I can't hear you. Hello? Okay, I don't know what's the question. Okay, any question with this?
Sir, I think her mic's not working. I think she's typing it now.
Oh. But who did? Who asked?
Fatma.
Oh, okay, okay. Yeah, you typing, Tame? I don't know, I think her mic, her speaker is also not working. She can hear me, I guess. Okay. Okay, so the last step. So this here, this? Okay. So the only thing, is this okay? Yes? Okay, so that's it. So I replace secant y by x because secant y is x. And I replace tangent y by this. Okay? All right. So this is for the third one. So let's do 3 more, and then we'll do some examples. Okay, so let's go the third one, which is the arc cosine. Prove that if f of x is equal to the arc cos of x, then f prime of x is the same thing, square root of 1 minus x2, but with a minus. Okay, so same idea. Let's go. Arc sine of x, arc cos of x equals y, then x is equal to the cosine of y. Then I derive both sides. 1 is equal to negative sine y times y prime. So here's where the minus comes from, as you see. And so y prime will be negative 1 over sine y. Right, we're good?
Yes.
Okay, so now I'm going to do my triangle, just like before. So this is y, 90 degrees, and I have here cos of y is x over 1, right? So x over 1, which is cos is adjacent over hypotenuse, so adjacent over hypotenuse. And so I could find this side now using Pythagoras, 1 minus x2 square root. Okay, and then I will now find an expression for the sine of y. So just to remember, a reminder that sine of y is equal to the opposite over the hypotenuse. Opposite is 1 minus x2 square root over hypotenuse, which is 1. And I replace now my sine y by this, and I'm done. So minus 1 over sine y, which is root of 1 minus x. Proof is done. Any questions? Okay, it's always the same thing. So proof. If f of x is equal to arc cotangent of x, then f prime of x is same thing as the arctan, but with minus. So again, arc cotan equals y. This means that x is equal to the cotangent of y. We derive both sides. 1 equal derivative of cotangent is negative cosecant squared of y times y prime. And so y prime is negative 1 over cosecant squared y. All right, that's what you did, I guess. So we move up here. And then we use the identity that the cosecant squared of x is 1 plus cotangent squared x. Let's use this identity here. And so y prime is negative 1 over cosecant squared is 1 plus cotangent squared. And so y prime is negative 1 plus cotangent is x. So x2, and I'm done. Okay, this is okay? Yeah, you getting the hang of this? Okay, good. Let's do another one. Last one. So prove that if f of x is equal to the arc cosecant of x, then let's show that f prime of x is 1 over x root x2 minus 1 minus. Okay, so again, arc cosecant of x equals y implies that x is the cosecant of y. Let's derive both sides. So 1 equals derivative of cosecant is negative cosecant cotangent times y prime. And so y prime is negative 1 over cosecant y times cotangent y. Okay, so until here we're fine. And now cosecant y was very easy because that's, we know it's x, so this is going to be x. We just need an expression for the cotangent. And for this, we need our little triangle. So again, x is cosecant, remember, is 1 over sine. And so this means that sine y is 1 over x. And now I could draw my triangle. Okay, so the angle here is y, and then I have opposite, my sine is opposite of hypotenuse, so in the opposite I'm going to put 1, and the hypotenuse I'm going to put x, and here I'm going to use Pythagoras, x2 minus 1 squared, square root. There you go. This is a right angle. Okay, and now I need the cotangent. So the cotangent of y is equal to, so the cotangent is the adjacent over the opposite, say for the cotangent. So the adjacent square root of x2 minus 1 over the opposite, which is 1. And then I just replace everything here and I'm done. So y prime is minus 1 over cosecant yx, that's x, and cotangent y is square root of x2 minus 1, and I'm done. Okay, that's it. We proved all 6. Okay, let's do a few examples just to get used to that. Okay, any questions? Okay, that's good. Let's go. So example, find f prime of x. So first of all, let's say f of x is equal to the arc sine of the square root of x. Okay, so let's go. So f prime is, so the derivative of arc sine, remember, is 1 over the square root of 1 minus what's inside. So it's 1 over the square root of 1 minus what's inside squared. Times, right? We have a function, so chain rule. Good. And that's it. So it's going to be equal to 1 over the square root of 1 minus x times the derivative of the square root of x is 1 over 2 times root x. Any questions? Okay. Number 2. Let's say f of x is 2 to the power of the arctangent of x2. Yeah. Okay, so let's go. So the derivative of a number power of function stays 2 to the power of the arctan of x2 times ln of 2 times the exponent prime. Arctangent of x2 prime. Okay, so this is an exponential function, right? A power x, a power f of x. So I need to derive this now. 2 to the power of arctan of x2 times ln 2, and the derivative of the arctan is 1 over 1 plus the inside here squared. So x4 times the derivative of x2, which is 2x. And any questions? Okay, you guys seem to get it. Either that, so I'm going too fast and I'm overwhelming you. I hope is that you really get it. Okay, let's do one more, and then I'll show you logarithmic differentiation. Number 3. So f of x equals to, let's say, x2 times r cosecant of 2 power x. Okay, so notice here that you have a product. So there is going to be a product rule here. So x2 times r cosecant of 2 to the x plus x2 r cosecant of 2 to the x, of course, u prime v plus u v prime. That is 2x times r cosecant 2 power x plus x2, and now the derivative of r cosecant, you remember this one? We just proved it. It's -1 over, so what's inside? So 2 power x times square root of what's inside squared minus 1. Times, let's not forget the derivative of 2 power x, right? So still a chain rule. And that's it, we're almost done. So it's 2x r cosecant 2 power x plus x2 times, so the derivative of 2 power x is, so there's the minus here, so minus, so 2 power x times ln of 2, that's the derivative of this, over 2 power x square root of 2 power 2x minus 1. And of course, the 2x's could cancel. Just going to make it nicer. And so I get 2x r cosecant 2 power x minus x squared ln 2 over square root 2 to the 2x minus 1 and above.
Sir?
Yeah.
Do you mind slowing down a bit?
Yeah.
Thank you.
So now look at this example here. Number 4. So find y prime, given that, let's say, y is equal to, so let's say sine x to the power of x. Okay, here's an example. Okay, so now we have a real problem because I have a function on the base and I have an x in the exponent. So I don't know whether to do the power rule, okay, whether to do the power rule or whether to do the exponential rule. I don't know. Stop here. So this is what I'm going to do. And every time you see a situation like this where you have an x in the base and in the exponent, you have no choice. You have to do what I'm going to do now. I'm going to rewrite it. Y equals, so sine x to the power of x. And I'm going to put ln on each side. I did not derive yet. I'm just putting a ln on each side. That will allow me to bring down the exponent. Okay, thanks to the rules of logarithms. Okay, so what do I have here? Ln y equals, so x times ln of sine x. Are you okay with me so far? And now I'm going to do the derivative of both sides using implicit differentiation. So let's derive the left side. So the derivative of ln y is 1 over y times y prime equals, and here I have a product rule. Okay, so I have x times ln of sine x plus x times ln of sine x. So u prime v plus u v prime. Okay, and now I could isolate y prime. So y prime is equal to y times all this. This is 1 times ln of sine x plus x. And what's the derivative of ln of sine x? It will be 1 over sine times the derivative of sine, which is cos. Okay, and then after that I'm done. I just need to rewrite the y as this expression and I'm done. So y will be sine x to the x times, and then I have ln of sine x plus x times cos x over sine x, which is cotangent x, or I could just leave it if you want. Cos x over sine x, and this is my answer. Okay, what we just did here, where we put a ln on each side, this is called logarithmic differentiation. Okay, so every time you see an x in the base and in the exponent, you have no choice, you have to do this process. Put ln, bring the exponent down, get everything on the floor, and then you can start working. Okay, there's one more situation where you will use logarithmic differentiation, but this we'll do it next class. It's going to take us 10 minutes and we'll be done.